Okay, so now it's recording. Let me share my screen so that we can get started. Okay. Can you see my screen all?
Yes, sir, we can see it.
All right. So as you can see, we had today and tomorrow to be NumPy and pandas. Unfortunately, yesterday didn't hold, so we make sure that we cover this session. Next week, these days, Saturday, we're gonna cover this. Sunday, we're gonna cover this. Another week, we're gonna cover this in the same date, and then finally we're gonna cover this. So expectedly now we have 3 more weeks, week next week and 2 more weeks, 3 more weeks anyway. We cover now 2 weeks. We can see we have 6 weeks in data science. We cover already 2 weeks now has passed, and this week also I think including is 3 weeks. So we have 3 more weeks. So within that 3 more weeks, we'll be able to, cover the yeah. We also have some stuff we will be doing in each session. We're gonna have our mentors as well to do some presentation, but for today we have something different, which I will discuss maybe at the end of the day. Okay, so we have Al-Amin today. I mean Hamza Nababa, he is our mentor for this week, and for NumPy, he will also, let me finish. We have something that he will coordinate concerning NumPy. Yeah, so let me share the screen and we can get started about NumPy. Okay. So what is NumPy? I believe we all had a bit of idea of what we can use NumPy for. We also did it in our Python 30 days. But today we're going to discuss more about it. So you can see NumPy basic, array and vectorization computation. And this lecture is basically based on this book that I shared. You can see NumPy basic arrays and vectorization computation. So this is basically on this chapter. And also tomorrow, the next chapter, pandas, will be based on this chapter. So NumPy is basically used for numerical computing, and it's done, as you can see, from numerical Python. Is a library that performs numerical calculations. So we all know that if you are in computer science or mathematics or something like that, you did something like linear algebra, or you know some stuff about mathematical functions that you can use. So and that's NumPy is used to do that. One of the key functionality or key things about NumPy is that it's very fast because it is implemented in C programming language. Yes, and NumPy is implemented in C programming language. And that's why it's, basically Python is slowest programming language, is very slow, unlike other programming languages such as C and C++. It's built on linear algebra. What this means is that everything you can do in linear algebra, like matrix multiplication, vectors, all those stuff. You may not know linear algebra, but linear algebra is one of the core principle in machine learning. Maybe also if you move to deep learning, you see that everything about deep learning, for example, is matrix multiplication, array multiplication, all those stuff. So NumPy is purposely built to do such kind of array or vectorization manipulation. So what the key concept in NumPy is array data type. So this is the key concept in NumPy array, because I can say, I said NumPy is used, for linear algebra. So linear algebra is based on array, giving you array of columns. So this is an example what we call an array. So an array is something that you can use to store data. You can see here we have index 0, we have index 9. So always Python array start from 0, and you can see 9. So you can see this is an array, and NumPy array have, because this is one-dimensional array, but NumPy array has n dimension. It can have one, we can say one dimension, n dimension is called array. One dimension is called array. Who can tell us array with 2 dimension? What is it called? Array with 2 dimension. What is it called? Maybe in mathematics or whatsoever. Who can tell us? Array with 2 dimension.
Vector.
Now, vector is 1 dimension. Vector, this is a vector. This is a vector.
It's called matrix.
Yes, it's called matrix. So it's called matrix. So if we have 2-dimensional array, this is called matrix. But if we have n-dimensional, we mean from 3 to 4 to n number to any number, we call them tensors. So if we move further to deep learning and whatsoever, you see you'll be doing everything about tensor. Everything involves tensor. So learning this array manipulation is very essential and crucial in your journey to data science, machine learning, and all other aspects. So one may ask, what is 1D array, 2D array, 3D array? So look at this 1D array, which is called vector, right? 1D array is called vector, right? And you can see what is the shape. So how many, like, for example, rows do you have? Like 7, 2, 9, 10, right? So this is called, the shape is 4,1, because the shape of array is tuple. You cannot say the shape of this is only 4. No. Even if, because it's 1D array, its shape is 4,1. So let's, we'll see. Okay, let me give you an example. So let's say we have A is equals to, okay, import NumPy as NP, and we can have NP dot array. Let's say we have 1, 2, 3, 4, right? So this is array. We have this array with these numbers. Let me use this number 7, 2, 9, 10. Okay. So we have this array. So for us, who can tell us if we want to see the shape of this array? What can we do? If you want to see the shape of this array.
A dot shape.
A dot shape.
So look at it. Can you see 4,1? So what I'm trying to tell you that don't be asked, given these, when you say, what is the shape? You just say 4. No. The shape of an array is a tuple. It's a tuple. We know tuple, right? So this is a tuple. A 1, 2, right? This is a tuple, right? So this is a tuple. If you remember tuple, we use this open braces, right? If we call, let's say, for example, can you see this is a tuple? This is tuple, right? Tuple. You can see tuple. So even if I give, like, if you want to define in Python, if you want to define tuple with only one element, you cannot say only one. Let me show you. Can you see what A is 1? But when I say what type of A is integer. But if I want to say this A is tuple, I need to put comma, even if it is only one element. So let me show you. What is this? Can you see it's tuple, right? So just give you an idea, this is something that we discuss in Python. I'm just trying to, put us more home to what that. So you can see this is 1D array. What about this one, 2D array? You can see because it has this, you can see this is 2, we can say this is 0 axis. You can see it's 2. So always the 0 axis comes first. And you can see we have axis 1. That is the second axis, because everything in Python, remember, it starts with 0, right? So even you can see we have 3. That's what. What about 3D shape? So you can see here we have 4, 4, we have 3, we have 2, 4, 3, 2. So this is 3D array, 2D array. All these one are called, this we call it sometimes vector. We call this one sometimes matrix. We call this one sometimes tensor. So that's basically the introduction. What is NumPy and what we can use NumPy for a lot of other stuff, right? So for example, you can statistical operation, broadcasting, everything, linear algebra, matrix, stacking. In fact, NumPy is one of the, core package that other things that have been built on. For example, like pandas. Without NumPy, pandas cannot exist because, pandas work on top of NumPy to inherit some other stuff to make it easier. In fact, if you move to deep learning, you see that even PyTorch, mimic NumPy, structure, how NumPy. So if you are well cumbersome with NumPy, when you move to PyTorch in our deep learning, you'll find it very easy to understand NumPy. Yeah. So, but NumPy, because it's very easy, it's very suitable, it cannot be used for many other stuff. So that's why Pandas was created to work on top of, NumPy to provide some functionality. So you can see while NumPy provide computational foundation for general data processing, many readers want to use Pandas as the basis for most kind of statistical analysis. So we use Pandas for statistical analysis. We use NumPy for computational analysis. What I say computational analysis, so maybe multiplication of matrices, multiplication of vector arrays, that is NumPy. But when you want to use data statistics or data analysis, data cleaning, you use Pandas. Yeah. So NumPy by Pandas, you can see there are a lot of, why Pandas and NumPy. NumPy is a Py for scientific computation. We support n-dimensional array. And Pandas is for data manipulation. So when you want to do data manipulation, data science, data cleaning, data mangling, data wrangling, everything, just use Pandas. NumPy is low-level library, while Pandas is high-level library built on top of NumPy. Can you see that? So Pandas was built on top of Pandas. And NumPy is mutable for this. So NumPy is faster than Pandas. Why? Who can tell us why NumPy is faster than Pandas? Who can tell us why NumPy is faster than Pandas?
Because you said it is built on C
programming. Yes, exactly. Yeah, so that's it. So again, why NumPy is important. So I'm just giving us now here the background, why we need NumPy and whatsoever, some of the important, but this is very important as well. One of the reasons why NumPy is so important for this is that it's designed for efficiency, for speed. So there are many reasons. There are two reasons that NumPy is its speed is better than Pandas. Number one, NumPy internally store data in contiguous block of memory. So let me show you. This is example of list, Python list. You can see Python list, right? So this is a list. Maybe you store numbers 1, 2, 3, 4, 5. Now, internally, what Python will do is that it will go to the computer memory and store this value like this, not contiguously. Like, this, you can see this one is stored here, this one is stored here, this one is stored here, not continuous. So, therefore, because it's storing this information in non-contiguous form, if you want to access this list, Python need to specify which position this information is stored in the memory of computer. It need to find, in this address, this is stored in this. So you can see there is some kind of overhead of, different places the value is stored. While NumPy store information in contiguous memory. So if, this information, NumPy will just store it in here in contiguous memory. So it only needs to know the first location pointer, the first location where the memory and the end location. And when it accesses the first location, then it can just do. So you can see it doesn't need to store or some other overhead for accessing and whatsoever. So this is one of the reasons why NumPy is, faster than Python. NumPy operation are complex Python loop. Okay, NumPy operation perform complex computation on entire array without the need for Python loops. So one of these reasons is that, let me give you an example for that. So let's assume here we have A is equals to this, right? So A equals to this. Now, how can I multiply, how can I multiply in a list? Let's assume this is a list. If you want to, multiply each number or add each number by 2, in Python list, you need to write a for loop so that it can, loop through each element and add it. But in NumPy, what we can do, I can say just A plus 2. what this happen is that it will add 2 to each and every element. No need of loop. No need of looping. This is what we call vectorization. This is called vectorization. So this is one of the key points. NumPy operation perform complex computation on entire array without the need for Python for loop, which can be slow for large sequence. NumPy is faster than regular Python because it's speed. So you can see this, if we have 1 billion in Python, you need to do looping, but this one, it just use vectorization. So that's one of the reasons. And you can see here, let's just see some example here of efficiency. Here I create NumPy arrange to create 1 million, list of items. And now I multiply it here by 2. You can see here I create NP arrange, I create a list. And here I multiply it by this. And when I multiply by this, we can see, the time it will take. And also we will be able to see the time here. So you can see it 896 milliseconds. So here, but here I'm doing the same thing, but with a list of Python list comprehension. So when we run this, you see that the time it will take, it is, larger than, the you can see this is micro OP second, but this one you can see. So just telling you that, NumPy is way much faster than Python and pandas. Yeah, so let me stop here if there is any question before I proceed. Umar Shehu.
Yes, sir. Assalamu alaikum. Hello? Assalamu alaikum.
Wa alaikum salam. Go on.
Okay, so my question is, can we refer to array as a list? That is the vector array, the 1D array. Can we refer to it as a list?
Yeah, so it's somehow a list in, okay, let me show you. Okay, in a list, we just use it, A equals to, this is how we create a list, right? 1, 2, 3. This is how we create a list, right? In Python. But in NumPy, the way we create a list is this. In fact, you can take a list, Python list. You can take, let me tell us, what kind of Python? You can see it's a list. But in NumPy, if we want to create something like this, okay, you can see the something, right? The something here I have.
Yes.
So I can say like this. I can say what type is it? You can see there are 2 different things. You can see this is list, but this is a NumPy ND array. Can you see
Yes.
that?
Yes.
Yeah. So you can see this is basically NumPy ND array, and this is a list. So this is a list, normal list from Python. But this is somehow you can see if it is an array in 1D, you can say it looks like a list, yes, but it's not list behind the loop. It's NumPy ND array. Yeah. Does that make
Thank you.
sense?
Yes, sir. Thank you.
Okay. Any question? All right. So I believe we understand why NumPy is faster. The information is stored in contiguous list of array. And number 2 is that, operation is done, on entire array without using for loop, right? So this is basically the bit of introduction, general introduction on why Python and whatsoever. So let's dive into NumPy and the array. So, yeah, so we already said that in NumPy, one of the key aspects of that is array, ND array. So here we already create array using oh, okay. You can see this one. So you can see this one. I have okay. Let me use this. A is equal to np dot array. You can see we have this is just like a a single array right here. So who is asking question? Yeah, it's ND
There's a
array.
question in the chat. Yeah.
Okay, what is it saying?
The first question said, Doctor, how can this shape 2, 3, 2 be interpreted in terms of rows and columns? Why the second question say is ND array means n dimensional array?
Yeah. Okay, so the first question, let's go over. So look at this one here, right? So because 1D array here, you see, we have this shape, for example. It's not like you can say you have something like this, you know, but if you look at this one, you can see we have something like axis 0, axis 1, right? So we have this one. But for 3D array, you're asking, we only have row and column, right? So look at this, is just to give you a scenario on what this means. We'll discuss this when we come to, I reserve this because I know this is one of the most difficult part of NumPy to understand this, for example, slicing and do, you know, all those stuff. We'll discuss, we have a separate session for that, but just for now, you can see you have this. That's why I just bring even the shape here to for us to see. You can see here you have something like this. We can see column, this is this. This is so here you cannot say this is row, column, you know, all the, because you have, you know, different dimension. But as I said, I will explain this more in when we come to the, you know, slicing and whatsoever. So I think I have something. I'll come over that one. In fact, I skip it, but I will do. Yeah. So okay, let's do this. So you can see here we have what we call letter, right? And then here you can see we have this. Now, this is basically an array, and we can see we can see that what is the shape of data. Data, the shape you can see is what, 2 by 3, right? What do you mean by 2 by 3? You can see here when I can do something like this, you can see I have one array here inside, then I have comma, right? Then I have another array, right? So if you look at this one here, you can see we have 2 by 3 because we have like 2 rows. You can look at it in this way, and we have this and this. You can see this is 2 by 3, right? If I want to have another, you know, another stuff, I can have another, you know, this like this. You can see. Who can tell us what will be the size shape of this one now? What will be the shape now?
3 by 3.
Okay, let's see. You can see 3 by 3. So I'm just giving you an idea what this means. This is very important as we move on. Okay, so let's do mathematical operations. So you can see I have there. You can see the content is 15, right? 1.5, you know, 1.5, 0.1. So when we multiply this by 10, you will see that this has been so here is clear output. If you are working on something, you can press here to clear the output, right? So let me run this. We can see this is our data, right? And I can see that this is the shape. And when we multiply, you can see this is 1.5, 0.1. So we can multiply by 10, and you can see we have 15. This is what we call vectorization. In fact, we can do addition, which we know 1.5 plus 1.5. You can see it gives us this, right? So this is what we call vectorization. Note that in this chapter, and throughout the book, I use standard NumPy conversion, always import NumPy. Okay, so what he's saying is that always, remember, when we are using NumPy, the format is we are saying import NumPy as NP, right? As NP. So this is what we're doing. So that we import the NumPy package. So wherever we want to use any Python NumPy function, we need to access it through NumPy. We say NP dot. I already discussed this in our session when we discussed classes. When you import any Python package, we use this short term because, in fact, you can say import NumPy, but here you can just say NumPy. So here, when I say import NumPy, I import everything in NumPy, right? I import NumPy, but NumPy sometimes the names of package is too long. So you look at it, this is still the same. So you can see here, I run it. But sometimes name of the packages are too low, or there are some convention in data science. So what we do is import NumPy as NP. So this NP is now alias, it's alias. What do you call it? Alias. It's alias. So it's alias in the library NumPy, right? So that's why we don't need to put NumPy. We can just put NP at this, and then here you can see we have this. Yes, question, Bala?
Yes, sir, I have a question. What about if somebody said impute NumPy without indicating as NP, and later on while working now, you just put NP? instead of to write the NumPy completely while you're working. So is it going to run?
No, nothing will run. So if I just have import NumPy and here, NP will not work anyway because you do not alias NumPy as NP. So two ways. If you say import NumPy, every time you want to use, just you need to put in NumPy every time. But if you say import NumPy as NP, you can no longer use NumPy. You can no longer you cannot use NumPy because you already alias it to NP. So here must be NP. I don't know if this is the question you are asking.
Yeah, that was the question, sir.
Okay. Okay. Yeah. So so this is what they are saying. So I already explained here that what we are doing is based on this book, NumPy, and tomorrow we do NumPandas. Okay. So this is very important point. An ND array is generic multidimensional quantity of homogeneous data. That's all the elements must be of the same type. Every array has shuffle indicating the size of the dimension and the type of. So what this means is that every data, when we are creating an array, they must be of the same, homogeneous data. Who can explain this? What is, who can explain what this idea means? It said all the elements here must be of the same type. What this means?
It means that the content of the array should always be the same. If it is integer, entirely should be integer. If it is alphabet, it should be entirely alphabet. If it is this thing, decimal point should be completely decimal point. That's what they mean by that statement.
Okay. Yes. All right. Thank you. Yeah. Okay. So let's move on. Okay. This is our data. I already discussed what is shape and already discussed what is T type, right? D type, data. Okay. So you can see the shape. We have this. You can see the shape. So we have another thing called D type, which is called data type. So let me show us here. Now, if I have this, A equals to list 1, 2, 3, right? I can see the type here of A, which shows me the type is a list, right? Now, what about if I have, this is a list, NumPy. What about if I have, NumPy array? NumPy array here, can we say what is the type of NumPy array? Can we say type, and put data here? Look at it. Can you see? NumPy array, right? NumPy array. It shows me NumPy array. But we have what we call D type, data type in the data, right? So here you can see here it tells us what kind of data is it is in float number, right? Because 1 point, any number with float, a point, we know float, right? So this is a float, it's not an integer. So this makes sure that you understand the difference between them. So here we can use the type to show the type, and we can use the shape to show the shape. So now there are different ways to create ND arrays, to create an array. We can use, which I already showed, for example, np.array to create an array, because this is a list, for example. We have a list of this, and for us to create ND array, we can have np.array, we can put the list inside. So here you can see we have an array, which we already showed. So this is nested sequence, like a sequence. So you can also, create array with nested sequence of list of equal lengths. So here you can see we have a list 1, 2, 3, 4. We have another one 1, 2, 3, 4. Can you see that? So we can save them here inside data, and now we can call np.array the data too, and you can see here we have 2 by 3 stuff, but they must be all the same shape. You can see that if we have different shape, we will have an error. So this is basically a way to create that. There are many ways. And now you can see the dimension. So we have another thing called ndim, number of dimension. So which dimension is this array? Which dimension is this array? You can see of 2 dimension, right? So if I have this, A is equals to NP dot array, right? And I say A dot ndim, you can see that ndim. So you can see this is one dimension. Remember, we have one dimension because this is one dimension is array, right? It's just array. Remember, this is one dimension, right? This is one dimension, 1D array. So so that one give us yeah, so that one give us dimension. You can see ND array is one dimension. Any question? Any question?
Good day, sir.
Yes,
Good day, sir.
I have a question. The difference between dimension and shape, please.
Okay, so dimension and shape, right?
Yes.
Right. Okay. So look at this one here. What do we have here? We have this, right? And it shows us, oh, okay, can you hear me?
Yes,
Yes,
sir, we
Doctor,
can
we
hear
can
you.
hear you.
Yes,
Yes,
sir.
we can hear you.
Okay, so he's asking, what is the difference between shape and dimension? So look at this one here. Maybe my answer will not be right, but you can see here we have the shape of our array. You can see we have this and we have this, right? This is shape. Now, what about if I say my data and beam? So look at this. What it gives us, it gives us the dimension of what? 2. Now, let me add something here just to make sure that. Let me add just to make this so clear. Give me a second, please. A second, please. I'm coming. Okay, yes. Okay, I'm back. Okay, so what I want to add here is just I want to add another example here that we can understand the difference. Okay. Oh, what is happening? Oh no. What did I do? Okay, let me just continue with the example of the 2D array. So as you can see here, when we call shape, right, it gives us a tuple telling us the dimension of the axis, right? But ndim represent the number of dimension of the ND array, number of dimensions. So if, for example, I wanted to change this to be like 3 so that you'll be able to see how it will work. So when we add like, the axis 1 here, it will be like 3. So ndim represent the number of dimension, the axis of the ND array. But shape, as you can see, it gives us a tuple of integers representing the size of the ND in each array. So here it gives us the size of the ND array in each dimension. Can you see that? So I don't know if this makes sense. For example, here, what we will expect if we run ndim is, for example, you can see 1D array. It tells us it's 1D array. Only it's 1D. When we run, ndim on this number of dimensions is 2D. We know this is 2D array, right? It will tell us this 2D. If we run ndim on this kind of, it tells us that it's 3D. If it is 4D, it will tell us it's 4D. So basically, it's just telling us, the number of dimension we have. But shape, you can see that it's just giving us a tuple on the tuple of what we have in each of the shape, the size of the ND dimensions. So I don't know if this makes sense. Yeah. Abdurrahman.
It's okay. Am I right if I can say that that ND, it is giving us the category, while the shape is giving us, is described something.
So for example, you can see the category, for example. I don't know if my discussion is quite good. What kind of array do we have? So we can see category is 1D array, is 2D array, 3D array, is 4D. That is ND. Yeah.
So it's okay, thank you.
Any other question?
Yes, Doctor, I have a question. So
Yes.
when you checked the D type, it shows float 64. And since there is also float 32, does that mean NumPy is always storing in float 64?
Oh, yeah. So when we have float 64, float 32, so what this means that the size that the variable is storing the information. So we have different kind of data type to store information. So by default, NumPy store the information in float 64. So that is it by default. But we will come together later, I think, where you can explicitly specify, the stuff. But also, I think also we can have this. Okay, here we have this. What about this? So who can tell us what is the meaning of this size? We have data, the size, it gives us 6. What does this mean?
The number of the entries in the rows, right?
Memory space, it's occupying.
Yes. So yeah, so that's it. So let's just put in mind we have this kind of stuff, like size and but who can tell me the difference between, because you can see here I call size, I call this D type, I call this ndim. But remember, one thing you will notice is that the other thing that I call, for example, if you are calling something on object, sometimes we put, for example, this like this. We call it why. What does it mean? Why? Who can give us answer? For example, now ndim, we don't have this. For example, when I called it, you can see it give me an error, but we just have it like ndim, D type. We have it size. Who can tell us answer based on NumPy what this size means? What this D type means? Because anybody with decent answer.
Because there are no functions.
Okay, because they are not function, right? Okay, yeah, they are attributes. Yeah, so they are attributes. So these are called attributes. So attribute. So you see, objects in Python, they have attributes. They have functions that can work on that object. So if an object has an attribute, so you just call the attribute like this without this. So this is something we discussed. If you go back to the object class and whatsoever, this is something really, yeah. Okay. Okay, we do this. We discuss shape and detail. So there are other. So here you can see we have seen one way to create an array. One way to create an array using function called np.array and provide the list inside. But there are many ways to create an array, special array. We have NumPy zeros, create an array of zeros, NumPy ones, NumPy empty, NumPy range. So for example, when I call this np.zeros, I provide number 10 inside. When I run this guy, you look at what would happen. It gave me what? Zeros, 10 zeros. Can you see that? What about when I call this NumPy dot zeros, but 3 by 6, you can see I pass a tuple inside. Make sure I look at this. This inside is a tuple. Anything that you see is passed within the, what do you call it? This brace, this one is a tuple. So we pass tuple. Don't just do like this, NP, this, and do it like this. Can you see that? This is not a tuple. So when you do like this, you'll be able to see that you basically have, the tuple. So when I run this stuff, you'll be able to see that I have 3 by, 6, right? So I have 3 by 6. So don't try to, try to put only one stuff here. They are always different. Any question? Any question?
Sir.
Yes.
How about if I pass an array in the zero function? What will be the outcome? Because I can say you pass a tuple in it. How about if I pass an array in it as the argument?
You say what?
I said in this np.0, which is a function, and you happen to pass a tuple in it as the argument. How about if I happen to pass an array inside as an argument, not a tuple?
You want us to pass something like this?
Yes.
Like this? Is that what you mean?
Yes, sir.
Okay. So this gives you something different, not what we expect. You can pass anything you like, but as you can see, this is what kind of array do we have here? What is the size? So let me show you here. X like this. Look at what we have here. Can you see that? You are passing to create, np.0 of this shape. Can you see that? So here we just pass previously we passed, we pass these, what do we call it? We pass a tuple to create that. So it's not only a tuple that you can pass, you can also pass a list depending on whatsoever you want. We have empty as well. You can see here we have, just like you can see here, I create previously what we have. You can see this is 2 by 3 by 2, and this is empty. So what this means that it's not creating an empty list, but it's initializing them with some other stuff. But we also have NumPy arrange. It's an array. You remember in NumPy in Python, you create a list, right? Let's look at what this give. This will give us a list of items from 0 to 15. You remember in Python, when you want to create a list, you just say equals to 0, 1, 2, 3. Can you see that? Up to what? 15, right? Up to 14 or whatsoever. But now in NumPy, you can use arrange to create this. So who can tell us the equivalent of arrange in Python? What is equivalent of arrange? Eh? Range. Yes. So when we have range, so you can see, no, okay. You can see it. This is range. So you can see this is, equivalent, is not equivalent with that, this create the same thing. Okay. Let's quickly move on. So these are some of the, functions in NumPy. We have array, you can see array, arrange. These are all the functions that you can use to create, NumPy ND array. A lot of them you can do. We have data types for ND array. The data type or AD type is a special object for information for the array you create. So for example, now, if we have this, you can see I have this is float 64, right? By default, when you create, this is a question that Sani already asked. When you create ND array, by default, it's a 64-bit. It comes with 64, and but you can specify the type of that object. What kind of data type is it? By when you basically define the array. You can see this is how we define it, right? But you can have, another argument. You can see the argument you have. So here you can see parameters. You can have D type. You can specify which is optional. So you can say I have optional desired data type for the array. If not given, the type will be determined at the minimum type required to hold the object in the screen point. So look at it. As I said, by default, so look at what it says. If not given, then the type will be determined as the minimum type required to hold the object in the sequence. So as I said, it's plus 64, maybe I'm wrong. Definitely think it's determined by minimum, stop. But when you are declaring, for example, all these numbers, integers 1, 2, 3, 4, whatsoever, then it's going to be plus 64. So this is it. You can see there are many other stuff. So for example, we have np.array. You can see it. Now we can, okay, no, since she gone up. So this is what we have. For example, you can see the data type is 64, right? But you can have np int 32. You can have the, specify this int 32, and you can see we have 32. So this is in some ways, the data type is very important when you are doing some kind of matrix multiplication. Especially in deep learning, sometimes you can see that 64-bit data type, 64-bit, stuff, and 16-bit operation and whatsoever, but this is not important here, but just for you to know. So you can see here we have different kind of data type in unit 8 whatsoever. So this is the shortcut for that. You can see float 16, have precision floating point, float 32. This is very important deep learning precision. It gives kind of flexibility. So but you can do what we call conversion. So here you can see I have ND array in this int 64, right? But you can convert it to another type. So you can see you can use what you call as type. So you can see it's array. I now call as type on top of it, and now call the plus 64. So even the type, you need to say np dot that plot, the type you want to convert. So you can see here when I run this and I call this guy, you can see it's plus 64. So this is what we call type conversion. In some situation, you need to convert your data type from one to another. Can you see that? Yeah. In the example integers, you can see we are cast to floating point. If cast floating point number to integer data, the data will be truncated. So you can see here there is some issues where, for example, here I have floating point 3.7, 1.2, 2.6, 0.5, 12.9. Now, what about if we cast these guys to integer? This means that 726 will be truncated. So let me run this and see what will happen. So when we tap to integer, you can see it's become 3.7 become 3, 1.2 become 1, 2.6 become 2, 0. Can you see that it becomes 0? So you should know what to cast and what to know. If you have an array of string of numbers, you can use as type to convert them to numeric as well. So here you can see we have np.array is 1.259. So you can see here this is a string, but maybe you want to convert them to numbers. So you can see np.type. Let's define them here. So you can see here numeric string here as type. You can see what kind of type you want to change it. You say it's float, and you can see they become float. In fact, you can also use another array data type to create your type. So for example, here we have np.arrange. We have np.arrange int array. So what is the data type now of np.arrange? The type, you can see it's int 64, right? We can see it's int because it's integer 10, right? So let's see another one here. Leave this object, we can see it's what float 64, right? Now, as you can see here, int array we know is int 64, right? Int array is 64. So if I want to convert its type to the data type of this object, this object is float 64. So I can call int array as type. What kind of data type? Instead for me to write np plus 64, I can even write, leave the data type. So it will return the data type of that. So that would also change it to, you can see, to float from point. Instead before it was basically, integers 1 to 10. If you call int array here, you can see it. You can see it's integers. So there are many things you can do with that as well. I think it's we are reaching time, but we need to quickly cover some stuff. So arithmetic operation with NumPy array, you can do a lot with NumPy. Batch operation on data without follow. NumPy users call this vectorization. So we have what we call vectorization. So what this means in vectorization, we create an array here. We can see this is an array. You can basically, don't need to use for loop, for example, to do multiplication. So now I can multiply array by array, this by this. You can see it will multiply. You can do subtraction. So this is array-based computation. You can do whatsoever you like, and it will automatically do that. This kind of stuff is what we call vectorization. In fact, you can do division. So in fact, what I'm trying to say that if without NumPy, you want to multiply this array times itself, you need to write for loop to take each element from this and multiply. So, but with NumPy, you don't need to do that. You can also multiply it with scalars. So for example, here I have this. You can see I have this, right? So I want to multiply each element by 2. So I can see this by 2. When I run this, you can see each element is multiplied by 2. So this is also another one. You can also comparison between the same type yield to build here. So let me show you also something. Now I have another array 2. And I have array, normal array. So we can see that this is 2 by 3, right? So I can do Boolean operation. I say array 2 greater than array. What this means that it will take, is this object, the first one, greater than this one? If it is true, it will return true. So let's run this guy. You can see it's false. So array 2, which is array 2 here, you can see 0 is not greater than what? The first element here. So you can see this is what we call array operation vectorization. So you can see it automatically take the first element and compare, is it greater than this one? And then you can see what it returns is a Boolean operation, whether true or false and whatsoever. Let me move on quickly to basic indexing and slicing, which is one of the most important part of NumPy. I would skip this, the detail of this. I will come back maybe later within the week, but this is very important that needs its own attention, a different lecture, indexing and slicing in NumPy. But I will just touch what we mean by that. So let me tell us here, we create an array here. You can see 0 to 9, right? This is an array. But if you want to select something, how can you do that? When I say array 5, it means I select the one at the 6th position, because this is position 1, right? Position 2, position 3, position 4, position 5, position what? 6. Can you see that? So when I have these, you can see it return this. So this is what we call indexing. You index. But what about if you want to, if you want from this to this? So we can see that we can use this 5. You can see semicolon 8. Who can tell us what will this return?
It will return 5 to 9.
5 to 9? Okay, let's. No, it's return 5 to 7. Who can explain this? It's return 5 to 7. Who can explain this?
Then the range
So
starts from the 5, 6, 7. That's also put semicolon at the center between 5 and 8.
okay, so what? Okay, now when I say this 5, what does this mean 5? Who can explain what 5 here means? 5 is telling us what?
The 5 is telling us index 5.
So what is index 5?
Index 5 is we have from 0, 1, 2, 3, 4, 5. So position 6 is index 5.
Okay. Position what?
Position 6 is index 5.
2, 4, 5, 6.
No. Position 5 is index 5.
5 is index 5.
Okay. Well, if you can see that
because it begins from 0.
wait, what you forget is that in range, when we index a number, at least I mean, so it returns the elements between our, what we have sliced. It will not return, the last index that we put, in indexing terms. That is it.
Yeah. So let's look at it. 0, 1, 2, 3, 4, 5. Is that correct? Here we have up to 5, right?
Yes.
Now,
it's 5.
when I say this 0, what does this mean? I'm indexing from where?
From first.
zero.
Eh?
From first.
From first?
First one. First one,
Okay,
that means 0.
When I put 1, what will happen?
It will index you 1.
Let me put this one so that you will not be confused with this. NP is this 5, 3. Don't get this 9, 1. So let me use this so that okay. Now, when I have this A 1, what will be the answer now?
6.
6.
So can you see that? Now, this means indexing starts from what?
0.
From 0.
Can you see that? So what about if we give this from this to this?
That is from 5 to 8, but 8 is excluded.
Yes, exactly. So this is what Alamin was trying to say. So the last one here, you can see here is what? Excluded. So the last one is not, what do we call it this? Inclusive or something like that. So here, the last position. So if I said this, okay, let me say this. 8, what would be this? Position 8, what is it? Can you see 8? But when we do this in slicing, in this indexing, the last one is not what? Included. Can you see that the last position here that we put here, something like this, you can see it's not within that. I don't know if this makes sense.
Yes, doctor, it really makes sense.
It makes sense logically.
Okay, so another thing I want to tell us is what we call broadcasting. So we have what we call broadcasting. So what this means that you look at this one, I have array from 5 to 8. Now I assign 12. This means that all the position between 5 to 8, 12 will be assigned. So let me run this guy. I run this. Can you see? 12, 12. This is what we call broadcasting. So you just assign, but it broadcasted to all the locations. Can you see that? Then another important things we may discuss is, NumPy does not copy. So let's see this. Can you see this array 5 to 8? What is it called? Array 5 to 8. Let me show us this. AR 5 to 8. Can you see this? We know this, right? Because we already assigned some value to this. We already changed this location to this, right? 5, 12, 12, right? So now I assign this to another new variable called array slice. So when I run this, this is the value, right? Now, which one is our original of our array, NumPy array? This array is original. You can see this is our array original. This is array original, right? ARR is our array original. But what I do here, I modify it is quanta, right? Just to modify some part. But my original array is array, right? Now, what I'm doing now here is that part of array that I sliced, that I took, I assign it into another new variable. Can you see array slice, which is this? Now, the thing I want to show you is that when you make any changes now in array slice, what will happen? Who can tell me? The changes will be reflected on the original array. Let me show us. So you can see now here, array slice, position 1. In 1, I assign 1, 2, 3, 4. Let's look at it. Can you see this? Because position 1 of it is this 12. This is the position. Can you see this? Okay, this is 0, this is 1. This position, we assign this number, right? So now when I call the original array, you can see this number is reflected. I do not change the original array. I just change an array that has been sliced on it. I think this may be confusing, right? Anybody get it before I come back? Anybody understand it before I come back?
Understand.
Yes, sir.
Okay. What I mean here is that, let me quickly come back. Here I create an array, normal array. Can you see that? This is the content. Now, here, for example, you see that I say, okay, I now have array, But let me subset of it. Let me change its value to 12. You can see subset of it, right? I changed it to 12. This is called broadcasting. Now, I said, okay, there is another problem that we want to show you. An important first that distinction from Python list in Python built-in list is that array slice are viewed on the original array. This is very important. Array slice are viewed on original array. So when you do slicings, they are viewed on the original array. Any changes you do on that slice will be reflected on the original, which is all not the same with the original Python list. In Python list, they are original. When you make changes, you just, this means that the data is not copied and any modification to the view will be reflected in the source array. I hope this makes sense because this is very, very important point. This is very, very important point. So here you can see I slice some part of the original array and assign it in a new array, which is array slice. You can see it. That the slice array, now I say, okay, let me change some part of the slice array, which I changed part of it. And we can see here the slice array that I changed. The slice array that I can change, you can see this position. So this means that this slice array is, the changes I made in this will be reflected on original. So this is why we have this one. So this is very important. We need to take note into. Yeah, the NumPy, as I said, is robust with a lot of stuff. Yeah, so if you want to, you know, slice will assign to all values. And if you want to, you know, slice all values to a particular number, let's see this. You can see we have this from beginning to the end. And now when we have the, you can see that, you know, the array slice here, what I mean here, the array slice here, if I want to change the whole value, so you can see, I say here to here 64, so you can see we have this. Yeah, so, but what do you want? How do you copy if you want to copy? So if you want to copy, you use this copy on the slice part. The same thing here, array 5 to 8 copy. So this copy. So any slice you do, anything you do will not change the original list. So you can see here we do copy. Even though I do this 133, it doesn't affect the original, you know, array. Does that make sense? So this I'm just touching because we don't have much time. But if you have time, I really encourage you to come to this chapter, NumPy array and vectorization. There are more details you can go over to and more explanation. But let me quickly again to move on to cover some other important part. Oh, I have a lot to cover. Or we can stop here, maybe. Okay. Okay, let me quickly go to see the RAM number. Maybe I can resolve some very important point that I can come over. We have what we call pseudo-random number generation. So in NumPy, we have what we call numpy.random, which is a package, you know, that can use to generate random numbers, right? But in Python, we also have what we call random module that can use to do, but NumPy 1 is much faster than the built-in Python. So you see that it's a lot of similarities between Python and NumPy modules. So let me show us here. I can see I call an np.random. So here I'm importing some random numbers for standard normal distribution. So you can see here, this is random numbers. So this is called random number generation. You can create a, you know, create random numbers. But these random numbers I created here, from the name random, you can see that what will happen now if I click? Will I have the same content of these random numbers? When I run this cell again, will I have the same content?
No, it will be different.
Sorry.
Can you see the numbers are changing different? Can you see that? These are called random numbers. So you have a lot of different kind of random numbers, but you just give an idea. I can see np.random. Can you see, you know, np.random? You can have many, many standard normal. Can you see standard gamma, standard normal, standard, something like that, you know. You can have many random numbers from them, but just, you know, you may come to them later in some cases, but just to understand that you have different way to create random number. So you can see here, but sometimes we need to have, you know, random number that can be repeated, right? That when we run, because here when I run this random number is generally, changing. But what is the essence of random numbers? So sometimes you want to do experiment and you want to create some random numbers to use them in experiment. So this means that when you created those random numbers, you run the experiment. When you come back, the random numbers will be changed and you will not have the same experimental result. So one way to do that is you need to specify where the random numbers start. Can you see that? So this is what we call explicit generator. Explicit generator. We provide what we call seed number. So this you can see, I say np.random, default random generator. Here I use create a different random number generator here. Now when I click this, now when I run this, you can see I have the same random number, even if I, can you see that? So this one is basically, you can see here, I create a very, seed number, seed. So I can call the seed RNG, the standard normal, and now ask the, NumPy to create a random number, but you can see this is that is why maybe in deep learning, you see that you will be creating a seed number that will allow you to replicate your results. So we have different kind of method, permutation, integer, standard normal that you can use. We also have, Python, what we call universal functions. So for example, here you can see I create a list in arrange. I can call square root. You can see square root. You can see vectorization. I call square root and it calculates the square root of every number here on top of this, right? This is called unary because we act on a single value array. We can also call exponential. You can see it calculates the exponential of each number in it. This is called unary. These are unary. Others such as NumPy add or NumPy this take two arrays. So we have other binary operations. So for example, here I have X and here I have Y. So if I want to find the maximum of these two numbers, so you can see I have this is array Y, this is array X. If you are using normal Python, you need to write a for loop to check which one is maximum among these. So if you call np.maximum X and Y, we'll just try to see, check, return the maximum in each case. So it will take what is the maximum between this first number and this number? What is the maximum between this and this? What is the maximum between this and this? What is the maximum? This is what we call vectorization. It will work on all the aspects in vectorized format. So you can see we have a lot of them: square, log, sine, all this one are vectorized, yeah. Okay. There's also another function called when that return, okay. Oh, I have a lot. I have 15 more minutes to go. Please bear with me because this is very important. Okay, so this is another function. I think this is very important. Let's assume here, I have a function here. Oh, no. Expression conditional logic as array operation. So here you can see I have a X array and I have Y array and we have some condition. Let me skip this one. In fact, this is just explaining a function called where when I run this guy, it will return either one depending on some condition. You can read that one. But what I want to say, mathematical and statistical method, we have a lot of statistical method in NumPy. One of them, for example, we can say what is the mean? It will return the mean of this one. So you can see here, you don't need to calculate, right? For loop function to calculate the mean. Calling mean on this can calculate everything. You can call sum. For example, it will sum all the numbers. You can see this is very easy. All this one, it can sum everything inside here. So this is also fun. Yeah. But also you can calculate the mean based on axis. For example, here I can say calculate the mean based on the column like this, based on mean of this column, mean of this column, mean of this column, or calculate the mean based of the row, this row, this row, this row. So you can specify the axis. That's why we said function like mean and sum take an optional axis argument to compute the statistics over the given axis, resulting in an array with one less dimension. So if I say along the mean, you look at it, can you see that? Along axis 1. Here array the mean means compute the mean across the column, while array some axis because you compute the mean across the row. So if you put 0, it will calculate the mean across here like this, sum all these and sum across the row. Yeah, so what about the, we have what we call Boolean. So we all know Boolean, right? So let me show us this. When I have this array, we can see this is array, right? Now, what if I say array greater than 0? So what this means that anywhere where the value is greater than 0, it will return true. If it is not greater than 0, it will return false. That is what we mean by Boolean. Boolean values are cost 1 if it is true, and 0 if it is what? False. So let me run this. Can you see? False, because this is less than 0. You know, this is true, or 1. So this is it. So because true, false is 0, true is 1. When I sum this file, I call this array greater than 0, it returns this. So what about the return value? When I say return, sum all the return values, what will happen here? Who can tell me? Who can give me answer? When I say sum all the return value, who can give me answer? What will happen? And tell me what will be the output.
It will sum.
It means all those that are true will be summed
Yes,
up.
exactly. So, yeah, so when I run this, you can see 7. So you turn 1, 1 plus 2, 3, 4, 5, 6, and 7 whatsoever. So this is it. And we have another function where something like any that tests whether one or more value in the array is true. So this has a lot of stuff that you learn, a lot of them functions, but just now know them, you learn. You don't need to cram them, but just know them. When the usage comes, you say, oh, I know this, you can just use it. So you can see here, I have an array here, and this stuff are too much. Don't try to say that you cram them or, no, they have usage and constant use with them, you become used to them. So bools that any. So for example, maybe you have an array, you want to find that the array is not false. Everything that is something you want to check. So you can use any. So any will make sure that if there is anything where there is true, it will return true. It means the array is not empty, there is something in it. We have another function called sorting that sorts some stuff. So I have this number. So I can call sort on top of it, and now it will sort everything on this file. So this is a sort function similar to what we have in Python. So thank you very much for joining. I think I took this one so fast, and in fact, I haven't touched and discussed one of the important part, which I will schedule to discuss with us because it's really important. But I think what I would say is that thank you for joining us, and do read this book if you have any other question, and we will follow up with exercises that you can practice so that you can master the NumPy. We have a lot of exercises in based on NumPy and pandas. And any of you that want to master NumPy and pandas, do so this week, because NumPy and pandas, if you know them, you learn them, you just finish data science. If you know how to manipulate pandas or like data science, you finish it. You don't have any problem to use that. So try as much as possible to see that you read these chapters to learn more, which is this. NumPy basics and getting started with pandas, which will be covered tomorrow. So tomorrow we'll cover pandas, and today I will share we'll share some exercise that you do with NumPy, and also tomorrow with pandas, so that along the way, 1 week we'll give you a lot of exercises just to practice your skills with NumPy and pandas, and you will exactly enjoy it and have a very strong foundation using NumPy and Panda. When we move on to the next stuff, in machine learning and data science, we don't need to come back and say, okay, this is how you do in Pandas, this is how you can do in NumPy. You already have a very strong foundation.
Good day, sir.
Yes.
Good day, sir.
Yes, go on. All right. Any question?
No.
Any question? Any question? If you have a question, raise up your hand, please.
Hello, sir. Hello, doctor.
Yes, go on.
Please, based on the information being shared yesterday, there is another session by you. And now I'm here you saying until tomorrow. So I just need to...
Oh, sorry. I thought today is Saturday. I was saying tomorrow. Yeah, today 2 p.m. we're gonna have Panda. Sorry. Yes. Yes, sorry. Yeah. Yes, Mutala. Yes, Mutala.
Yes, sir. Please, I'm going to ask a question, and it's not about today's session. I'm the Ghanaian fellow in the group, and last time I asked you, said I should contact Mr. Bala. So when I contacted him,
Yeah, is it about the data? Is it about the data?
Yes. Yes, sir. Yes, sir.
Yes, it's on the process. Don't worry, it's on the process.
All right.
Yes. Any other question? Any other question? Yes, Mama Dialwa.
Are you hearing me?
Yes, we can hear you.
So where should I use to lodge my assignment since I don't have any group?
No, just if you scale through the next stage, everyone has a group. If you are part of the second cohort, then stage 2, those people that move to the second stage, you have group. So do reach out to Bala Abdul Jalil to discuss this if you haven't seen your name. Provided you have scaled through, your mentor endorsed you as you move on to the next stage. So that is it, because everyone has been endorsed by his mentor in the team based on the submission of the assignment and other stuff. That is so.
There's one time he made the information, so I'm not out of line, so that my name is not there.
Okay,
once you say my certificate is not view, so the time he put it, my phone has get fault.
Okay, so we can discuss this on Telegram. We'll follow up this on Telegram about this stuff.
Yeah, thank you, sir.
Any other question? Yeah, we'll upload the recording immediately. Yeah. Oh, with
thank
previous.
you, sir.
Yeah, the previous one, I hope, the previous last week, there was breakage about the recordings, I'll try as much as well to see that I will be able to upload it. But today we'll upload today's session that I just finished and also the last week one. Sorry for that, we can upload it. Any other question?
Thank you, sir.
Any other question? Okay, Bashir Ilyasu.
Good day, sir.
That's good day.
Thanks for the presentation, sir. I realized while presenting, you showed us how to check the size of the arrays. I was wondering, if you have already declared an array, how do you reshape that array using the NumPy?
Oh, that's also one of the even in the chapter I show you, you'll not be able to reshape it, but there is last chapter called Advanced NumPy. There is way to reshape arrays. This is very important, even for example, in deep learning, shaping and reshaping. This is one of the core part of, knowing the details. So this is something that I think in our class, we may not discuss it. Even the chapter I asked you to read, you cannot shape it, but there is advanced NumPy in appendix on the chapter. You can read it. That you will be able to see how you can reshape matrices and whatsoever. In fact, when you move to the next stage, for example, in deep learning stage, this is one of the core things you will be doing, reshaping array to make sure that the dimensions are correct to do multiplication, to do whatsoever. So yeah, but I think in this class, we will not discuss reshaping the arrays. Yeah, thank you very much. Any other question? All right. So thank you very much for joining us, and do join us, please, at 2 p.m. Where we discuss pandas. This is very important. As I said, NumPy and pandas, they are the core. They are the basic. They are the foundation. When you miss them, you will definitely be missed along the way. Please do join us, and we'll learn together. Thank you very much, and happy to see you 2 p.m. Thank you. Bye-bye.
Thank you. Very grateful, sir.